Hey guys, how you doing? I just want to go over 6.1. Okay, so a random variable, this is the workbook on 6.1, and this is, I'm now on page 110. Well, I'm sorry, 111 rather. A random variable can be classified as either a discrete or continuous depending on its possible values. If it takes a fixed, finite, or infinite set of possible values with gaps in between, then we call it a discrete random variable. All right, example I gave is either age or number of people or even shoe size, right? You can have decimals for discrete, they just have to have gaps between them. Shoe size, like, usually do it by halves. You have 6, 6.5, 7, 7.5. If a random variable takes on any value in an interval of numbers, it's continuous. I gave an example as like weight or temperature, all right? You can have any value, it can be any decimal. There's no gap. To describe a random variable, we follow the same process describing a probability model. First, define the random variable x as a numerical outcome of a random process. Next, indicate the possible values of the variable. Finally, give the probability that each value occurs using a table, formula, or graph. Okay, no problem. So, consider right here 2 4-sided dice, each having labels 1, 2, 3, or 4. Each having sides labeled 1, 2, 3, or 4. Let x equal the sum of numbers that appear after the roll of the dice. If x is discrete, is x a discrete or random variable? Sketch the probability distribution of x below. Obviously, x is discrete, of course, because your sum is just going to be actual numbers, right? And they're going to be 1 unit away from each other, okay? So if we're looking at the model, we can do a chart first. You can do like, one of these things right here where you're actually showing each one, and then you would have to add them all up. All right, a little bit more of a pain. I wouldn't really go for this way. I would just make a little chart right here so you can show all the sums right here. All right, so let me actually show this from scratch. All right, we know first row it's 1, 2, 3, and 4, and the second row is 1, 2, 3, and 4. So if we're doing a sum right here, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, and 1 plus 4 is 5. Then we're just adding, right? 2 plus 1 right there, 3, 4, 2 plus 3 is 5, 2 plus 4 is 6. Then we have 4, 3 plus 2 is 5. Then we have 6 and 7. Finally, 4 plus 1 is 5, 6, 4 plus 3 is 7, 4 plus 4 is 8. And we know the probability of each of these outcomes right here is 1 over 16. How do I know that? Well, think about it, right? If I got, let's just take a random, outcome of a roll of the 2 die, right? Let's see, the first number I got from the die is 3, and the second number was 1. Well, the probability of getting a 3 is, well, there's only 4 sides, 1/4. The probability of getting a 1 is also 1/4, and 1/4 times 1/4 is 1/16. Okay, so that's the probability of each of these outcomes right here. All right, so no problem. Let's get right here. Let's try to figure out, because we have to graph this, right? The probability of each of these events right here. So we're probably getting a 2. Well, I only right here have a single 2. It's, whoops, sorry. It's a single 2 right here. And my screen is being weird. But anyway, we only have a single 2 right here. There it is. Okay, so that is just going to be 1 over 16th. The probability of, and by the way, I'm going to put this as a decimal, 1/16 equals 0.0625. Okay, probably getting a 3. Well, that's 1/16 plus another 1/16, right? Which is 2 over 16th, and that is going to come out to 0.125. There we go. All right, probability of getting a 4. That's going to be 1/16, 1/16, 1/16. That'll be 3/16, right? 3/16 is 0.1875. All right, probability of getting a 5, that's just going to be 1, 2, 3, 4, 4 over 16th, which is, of course, 0.250. Probability of getting a 6, it looks like we have 3 6s right here. So that's 3 over 16th. And that is going to come out to, once again, 0.1875. Probably getting a 7 is 2 over 16. That, again, comes out to 0.125. And probably getting an 8. There's only one single 8. That is just going to be 1/16, which is 0.0625. All right, awesome. So let's take a look right here. All right, if we're going to go and graph this right now, all right, remember right here, what you have to do is you have to look at what is all the sums. The lowest sum is 2, the highest sum is 8, and the sum is going to be on the horizontal axis. That's why I put from 2, 3, 4, 5, 6, 7, 8 right there. I labeled it. Now, why did I put the probabilities as 0.05? Well, I look at all my probabilities I have here. I have from 0.06, and the highest one is 0.250. So I just kind of surmise right there, I'm going to start at 0.05. and just go up by 0.05, right? And that will get me up to 0.250. You could have done it by 0.10, I suppose. That would have been okay. You know, 0.10, 0.20, 0.30 would have been probably all right. But anyway, so I labeled it from 0.05 to 0.25. Make sure you label each of the axes. The horizontal axis is sum of the two rolls. The vertical axis is probability. All right, and then I just go ahead and do that. 0.0625 is right there. 0.125, a little more up. 0.1875 right there. 0.250 right there. And then you just, right here, the rest of them is 6 is 0.1875. 7 is 0.125. 8 is 0.0625. All right, and you can see how I got them all right there, right? All right, so there's your graph. Let's go to 2. If somebody rolled the dice 10 times and got a sum of 3 or less each time, would you be surprised why or not? All right, so what I want to try to get right here is, in this case right here, I want to try to get the expected value of, right here, getting a sum or 3 of 3 or less in at 10 rolls. How many? The expected value of getting a sum of 3 or less during 10 rolls, when you roll it 10 times. First of all, we just have to get the probability of a sum of 3 rolls or less, okay? So let's see here. It looks like 3 rolls is 0.125. Let me actually just write this down so this makes more sense. I'll erase this. So 3 or less. 3 is 0.125. And the probability of 2 is 0.0625. So I'm just going to add 0.125 plus 0.0625. And I'm going to come out to 0.1875. So the expected value right here of a sum of 3 rolls or less. Okay. Actually, I shouldn't say expected value of x because that assumes that we're talking about the previous problem right there. So, sorry, I'm having issues with erasing this for some reason. All right, so the expected value right here of getting 3 or less is just going to be times the probability of getting 3 rolls or less is 0.1875. Okay. So we want to know the number of times we expect to get a sum of 3 rolls or less after rolling it 10 times, and we get 10 times 0.1875 is 1.875. Okay, so they said if somebody rolled the dice 10 times and got a sum of 3 or less all 10 times, would we be surprised? Yes. We only expect to get it about 1 or 2 times. So yes, we would definitely be surprised. I would be surprised in 10 rolls. All right. In 10 rolls, I expect to get a sum of 3 or less only 1 or 2 times. Okay, so yes, I would be surprised. Okay, there it is. And remember, the formula for expected value, don't forget, guys, is right on your formula sheet. If you go to Google Classroom under formula sheet, it's actually right here, right? That's the sum of x times the probability of x, right? And there it is right there. And the standard deviation is right there. And let's go to the next problem. Okay, in chapter 1, we learned when describing distributions of quantitative data, we should always note the shape, center, and variability. The same holds true for random variables. In order to make inferences, we need to know what is considered a typical value of the random variable being examined, as well as how much variation around what value we can expect to see. As with distributions of quantitative data, the center of a random variable's probability distribution can be described by calculating the mean. All right, so center, we're talking about mean. However, in the case of random variables, the mean or expected value is a weighted average, taking into account the probability of each outcome occurring. Likewise, the standard deviation of a random variable takes into account the probability of each outcome occurring, giving more weight to those outcomes that are more likely. Make sure you get comfortable with the formulas for the mean and standard deviation of discrete random variables so you can calculate and interpret the center and variability of the probability distribution. So remember, I said you could do these on the calculator. All right, so we'll look at doing it on the calculator, but we'll do it. I'm going to do it by hand and on the calculator so you're comfortable with it. All right, calculate and interpret the mean and standard deviation of y. Y is the number of goals in a random selected high school hockey game, has the following probability distribution. So this isn't very long, so it's not that bad. And remember the formula right here. The mean's easy. It's just going to be basically your outcome times the probability plus the other outcome times the probability plus the other outcome times the probability. All right, we have it right here. It's right here. It's the sum of x times p of x sub I, right, is what we're saying. So in this case, y times p of y sub I. And it's just the sum right there. So that just means we're just going to say 0 times 0.155 plus 1 times 0.195 plus 2 times 0.243 plus 3 times 0.233 plus 4 times 0.174. Okay, now this is pretty easy to do by hand. All right, so you may not want to do it on the calculator. However, the standard deviation is a little bit harder to do by hand. So sorry, I'm having issues with my erasing. I don't know why that is. Okay, so I'm going to actually enter this into the calculator. And remember, if you do this in the calculator, okay, all you have to do is just say, let's say you're doing it in the calculator, you would just say tech. You would still start out expected value of y. And we're just going to say, right, we just do the first one. Plus dot, 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 plus, and the last one. 4 times 0.174. Awesome. All right. So let's do the whole thing in the, just have the calculator figure this out for us. Sorry, computer's a bit slow for some reason. Not sure why that is. All right, so let's see here. We're going to go to Stats, Edit. Let's get rid of everything on here. Remember, clear, enter. Go up here, clear, enter. All right, cool. Let's enter all this stuff in. So we have 0 to 4 right here. And then right here where it's at 0.155. Oops. Okay, the next one is 0.195. Then 0.243. 0.233. And finally 0.174. All right, cool, got it. So all we have to do is just press stat and just go to our one var stats, right? L1 is list, frequency list, make sure you put it as L2, right? Calculate, we got it. Okay, so my mean is 2.076, okay? Right there, that's my expected value X bar. So that is going to be 2.076. All right, standard deviation. All right, that's going to be right there. And we're talking about y, so just say sigma of y. And by the way, the mean and expected value is the same thing. So you could actually also put that as m of y, or you could display expected value of y. It means the same thing. So the standard deviation, all right? So if we're doing this by calculator, we still have to do the first and the last one, right? Remember, the book did say that. So let's look at the formula for standard deviation. remember what here? It's going to be the square root of the sum of the actual value minus the mean squared times the probability. Okay? So let's try it. Let's take a look right here. So the first one, the actual value, I'm sorry, it's the square root, first of all. And the actual value, all right, minus the mean. Well, the mean is right there, 2.076. And then we're squaring that. And then we're going to multiply that by the probability, which is 0.155. Okay? All right, and then right here, we're going to go and just put dot, 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 and let's do the very last one. So remember, actual value, which is 4, minus the mean, which is 2.076, squared times the probability, which is 0.174. Remember right here, standard deviation is the, if you're asked to interpret it, the average distance from the mean. Okay, so let's take a look. So I'm just going to do this whole thing on the calculator though. Sometimes they can be, this wouldn't have been too bad to do by hand, but some of them can be very long, kind of annoying. But anyway, it's already right there, right? We already put it in. There it is, 1.318. All right, if you want to go to 4 decimals, that's fine, 1.3184. There we go. Okay. And again, all you have to do is do the first, and then dot, dot, dot makes the ellipses, and the last. All right, and that's good. All right, let's look at number 2. The weights of the Tyler boys follow an approximate normal distribution with a mean of 34 and a standard deviation of 3.5 pounds. Okay, so the mean is 34, and the standard deviation is 3.5 pounds. All right, this is just a different problem. Don't forget. All right, so this actually is just scroll here, so we don't have to look at the first one. Suppose you randomly choose one Tyler boy and record his weight. What is the probability that the randomly selected boy weighs less than 31 pounds? Okay, no problem. So this is what we have to do right here, remember. I'm going to go and draw a little graph right here. And that's a normal curve, right? So we'll say the mean, which is 34 right there. Standard deviation is 3.5. So 34 plus 3.5 is 37.5. And 34 minus 3.5. All right, 34 minus 3 is 31. And then minus another 0.5 is 30.5, right? Now we're trying to find the probability that the boy weighs less than 31 pounds. So 31 is about like right there. And less than, we're going to shade to the left, right? There we go. So I'm going to go and say right here, normal, this is a different color. So I'll say normal CDF. Okay, and remember how we do this, right? We can just look at the graph. We have the lower. That's, I'm just always just put negative 10,000 there. Upper is of course going to be 31. The mean is right there, which is 34. And my standard deviation, just put SD, and that's 3.5. Okay, there we go. So I'll enter that into my calculator. Second distribution, right? Normal CDF, there we go. So the lower is negative 10,000. All right, upper is, of course, right here, 31. Mean is 34. And standard D is 3.5. There we go. Got it. And it is 0.1957 rounded off. So right here, that's the probability that a randomly selected boy weighs less than 31 pounds. So the probability that X is less than 31 is right there, 0.1957. That should be good enough right there. Okay? All right, guys, have a good day.